Hello guys and welcome back to the sim here in the UK. Now before I moved halfway across the world I started this Cessna project, and this was supposed to be a nice quick easy project that was portable. Well, this is as far as I've got. Let's get the lower panels done, the throttles, the fuse panel, and still waiting on the second Garmin 1000 here because I'm on about revision 27 if I'm perfectly honest. Anyway, let's head over and get the bottom panel assembly created today. These panels here are the backplate panels, and they're all designed to slot together to make one large panel, and they're designed to fit on the CR10, the Creality CR10 printer. Let me grab panel 1 and got a 8mm M4 countersunk screw, and that's just going to screw in there like that. And this one. And you can see this is going together quite quickly. We've got the final bridge support. And now we're struggling to fit it on the table. And there we have the main lower panel assembly all built. It's a bit flimsy right now, but hopefully when we get the panels on top, it'll really stiffen it up. These two panels here go together in the center there, and they're 3D printed. The text is raised and then painted with a white paint pen. It's enlarged specifically for 3D printing. And this panel should go onto the very first assembly here. This is the first time I've done this. It looks good. Next up we've got the throttle panel. Again, 3D printed, and that's going to go onto this section here. Really should help stiffen things up. We need 4 more screws. So next up, we've got the fuse panel in front of us, but we need to populate it with the dummy CBs. Originally, I created these CBs in 3 parts. These were filament printed actually on the Ender 3. And you can see that I used silver for the base. There's a black core in the middle, and there's a cap, a black cap that goes on here. They look okay. In fact, they do look quite respectable from a little bit of distance away, 12 inches or so, but you can obviously tell that they are 3D printed when they're up close. Then I had the idea to resin print them. The text again is raised, so you can really easily use a paint pen to fill it in. And these are printed in 2 parts. So you can see the body is actually super smooth. It looks really good. And then we've got our little cap. Get my big fingers out of the way because these are actually quite small. And that goes over the top. For both the 3D printed and resin ones, all we have to do is put a dab of glue. I'm using super glue. There it is. On the sides. And creating the dummy CBs is as simple as that. Going to move these to one side. And you're not actually going to see me fit the resin printed ones to this panel because it all become clear a bit later on in the video. Now you may notice that these CBs have got holes in the bases as well as the back plate in the fuse panel here. Each one's got a hole in it, and they were designed for M3 screws. However, M3 screws are expensive, there's a lot of them, and they're just not required. After all, these are dummy CBs, and super glue works a treat. And there we have all our CBs fitted. So basically this whole panel at the moment is currently 3D printed. Makes it extremely cheap and easy to achieve at home. Now that I'm back in the UK, I've managed to get myself a laser machine. I'll probably keep mentioning that. And that's where this panel comes in. And that's why I didn't fit the resin CBs to the 3D printed panel because I've got this beauty. This has come out really well. You can actually get these. I made extra, so anybody wants these for this design, you can get them on the website. The text is perfect. The resin printed CBs look amazing. And best of all, it's fully backlightable. Next up, we've got our Magneto switch. Now, this was designed to be as simple as possible and use any key. So the inner barrel here, this is a window key from the double glazing that we've got in a UK house here, and it just fits in, it just slots in. A screwdriver could be used. There's no locking mechanism. It's just there to look like the real thing. Got our 1x12 pole rotary switch, and we need to set 5 positions on it. So I'm moving it all the way anti-clockwise, and then I'm just going to count 1, 2, 3, 4, 5. So I'm just going to put this into the 5th locking hole. There we go. Count them back. So we're in position 1, 2, 3, 4, 5, and it locks off perfectly. I'm going to put the back plate on, locate the locating tang, and put the nut on. Nice and easy. So when you put the barrel on, rotate the rotary switch 2 clicks clockwise, 1, 2, and the vertical line of the barrel wants to be at the top point of the assembly here. So it points directly to the 12 o'clock position. We can put our outer case on, like so, and then just put a couple of screws in the back. There's our dummy Magneto switch. Let's put this into the panel. So now we get to test it out. In goes the key. It's in the vertical position, which is the left start, over to right, over to off, and it can't go any more anti-clockwise, and all the way to the way to start, and it goes and stops at start. Now this version, as I say, does not return to the both position. So if you leave it in start, it's going to constantly be in that position. The next version, which I'm about to show you, actually does return. Let's move this one out of the way and bring in version 2. Version 2 is a bit more sophisticated, it's a lot more expensive, and once again you can get it on the website. This one has its full 5 positions, but on the very last position when we go to start, you have to hold it in position, because if you let go it springs back. Now hopefully that's just like the real aircraft, and it works really well. Also, we've got a proper lock and barrel. The aesthetics look really good. It's all plastic, it's all 3D printed, and we've still got the original 12 position rotary switch at the back there. How do we build these? Exceptionally easy. Now, I've made loads of these for the store. They're printed in black PLA because they look a lot better. It hides them. For the purposes of the camera, I've printed this prototype one in red, and hopefully you can see a lot clearly. The very first thing we need to do is open up our barrel locks, and I use 16mm length ones. Open it up because we've actually got to mod this barrel before we can use it. And the reason we have to do that is because originally when they come, they only turn 90 degrees. They do have a rotation lock internally. Very first thing, we've got to take off the big screw at the back. We'll be using that later. And then we've got to take off this lock tab here. It's only pushed on there, and with a Stanley knife, be careful, and then just pry it up and off it comes. It's as easy as that. We need to keep that part because we're going to be putting it back on. Make sure the key is inserted into the barrel. That will hold all the parts in. Straight away, we've got a little 2mm ball bearing here. It actually might be 3mm, but we're just going to put it to one side and take it out. And if you look very closely on the inner barrel here, you can see this tang that's formed in the metal. It's actually cast. We're going to put this in the vise and file it down so it doesn't exist. Got my file, and we're just going to gently file that tang away. You can see that I'm using a half round file here, which is not ideal, but during the move I seem to have lost all my standard files. Hopefully you can see that tang has been completely removed on camera now. And the way to test it is to get the outer barrel without dropping it, put it back in, and it should turn a full 360 degrees now, which it does. That's that part done, and that's the hardest part of the build. So let me put the file away, not going to need that again. And we're going to put the compression lock tab back on. And it just pops on really easy. Just forcing it down. There we go. So now it can't come out and our key works. I'm just going to take the blue protective film off because it gets in the way otherwise. There we go. Don't need that anymore. Key back in. The next important thing is to grab the back case, or the rear case as I've named it. And then we've got two, and these are 7.1mm external diameter springs. They're 15mm long and they're 0.8mm in wire diameter. Easily available from Amazon. I've got a whole bag of them here, bought from Amazon yesterday. And what we need to do is we need to insert these springs into the two recesses in the rear case, and they should go in quite easily. There we go. Let's showing it the camera light. There's one, and again for the second one, just going to push it in. There it goes. It's clipped into the base, and it just sits there. Hopefully you can see that on camera. Oh, that's a good view there. Good. We've got our 12 position rotary switch. Again, it's got the ident hole there. We've got the locating tang on the unit, and they just go in together. Use the lock nut that came with the 12 position switch and tighten it into position. Nice and easy. Then we've got the spur gear adapter. That's this little red gear here. That fits onto the splines of the rotary shaft, and we can turn it. There we go. That's that part complete. Put it to one side. Then we've got our front case. So we've got our barrel lock. That's going to go into the front case. We've got our big barrel lock nut. That can now go on. Then we've got our adapter shaft. Now this has to go on in the same direction as the key. So the key wants to be vertical, and the vertical part of the adapter shaft need to align. Hopefully you can see that the key is in line with the adapter shaft and they're perfectly aligned. Here we go. We use the big screw that came with the barrel locked on the inside. It's a Phillips head, cross point. Just give it a little tighten and that's it done. What we need to do now is turn the centre rotary shaft fully anti-clockwise so it can't go any further, like so. And then we want to move it 2 clicks clockwise. There's one, there's 2 clicks. That means it's perfectly aligned in the vertical position, the 12 o'clock. We've got the key in the 12 o'clock position. And we're going to join the 2 halves together. I'm just giving it a quick test to make sure it's right. There we go. So that's off, left, right, both, and start. Good. That seems to be tuned. I'm going to put some screws in the back. Now these are M4 by 30mm screws. There's one. There's 2. So that is the lock fully assembled. I'm going to put the key in. So that'd be the off position. Then we've got left, right, both. And hopefully now when we go to a little bit further round, the key returns. And it does. All the way back out and off. That is version 2. Works a treat. And that's what it looks like in the real unit. Let's bring the MIP back in, the instrument panel. That's a little bit heavier than I remember. I'm going to lay it down. And we can bring our panel in that we just made. And that is hopefully going to slot in there. And it does. So I'm just going to pre-drill some screw holes. One. And that's what it's looking like so far. Next up, let's do the flaps panel. In front of me are all the parts for the Cessna trim panel. Two versions again. We've got the 3D printed face panel there, and we've got the laser etch panel, which is multicoloured and of course is available on the website. Put them to one side a second and let's get on with the build. We've got our back plate. Now this is going to operate by our micro switches, so I need to mount the micro switches to the back plate. That's the micro switches installed. As you can see, they're opposing pairs. Next is the detent unit, and that's what this little ball bearing is for. It's going to go in the back side like so. We're going to put the spring into the cap and hopefully that onto the assembly. Got these little screws here. I don't have the correct tool. Yes, I do. There's one. There's two. Just going to tighten that up, and then we should have our little ball bearing that can be depressed like so. Next up, we've got the centering mechanism, and we've got this spring here, which is quite a large one, and we're going to put that spring into the detent of the housing. We've got the lever assembly, and in the top of the lever we've got this recess that the spring is going to fit into the other side. That's just going to go in over the top. Make sure the recesses are lined up, they are. And we turn the unit over and we've got this M4 bolt to go in the top here. That allows the arm to move left and right. That's got a lid. Switch to the power drill for a bit more speed. Next up, we've got our hex bolt, and the head is going to go into the hex head recess here. In it goes. Got our lever assembly. That's just going to feed on there, and that bolt is then going to feed into there. To hold the lid on, we've got two M4 screws at the back here. With the bolt sticking out the other side, we've got this giant M6 penny washer, and that serves a very specific reason. I'm going to put the nut on, and this is going to set how stiff the lever is. So we're going to screw that down. Way too tight for me. That's good. The next part is to put the servo on, and this is for the trim indicator. Because I'm not going to electrically connect this at the moment, you need to find the servo neutral position. Normally there'd be a little screw that goes into this servo here. I'm not going to attach this right now because this is going to need to come back off, so when I program it, the servo is in the neutral position. But for this build video, I'm just demonstrating how it goes together. The servo and the arm is just going to slot into position there, and I've got these tiny little M2 screws that came with the servo, and we're going to use them to attach it to the base. There's one. That's it built. I'm not going to show the programming or the wiring, just like I haven't shown any of the parts that we've built in this video so far. I'll leave that to another video so we don't bore the pants of all the regular viewers. Let's get these face plates attached. So I'm just going to fit the laser engraved version straight onto this. Then we got some screws to go through the front. Bring in the drill. And the very last item is the knob. That's just going to push on. nice and stiff. And let me show you how this works. Because we've installed a detemp bearing here that's sprung loaded, if I push the lever over to the right, your left, and I can already feel where the positions are. It's actually very distinctive. There we go. And the whole reason why the lever is sprung loaded is because then you can't go from 0 to hero in one easy go. You actually do have to hold it over to the right to go down to the next detent, and again to the flaps 30 position. So there's 20, there's 10, and off or 0. And right here we've got the trim indicator. It's in red, it should be printed in white. That would make it stand out a lot better. I need to get on to do that. And that just moves up and down with a bit of servo action and a bit of Moby flight programming. So let's get the flaps unit fitted. And all we've got to do is feed the wires in, hold it over to one side, and that is never going in. Nope. Nope, 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 nope. Not fitting. Well, let's do this in two halves then. Take the screws back out. Put the back assembly to one side. Let's fit the face panel first. On goes the face panel, and I've got some M412 bolts here. So now that the face panel's fitted, we're going to fit this assembly from the rear. There we go. Pull these screws out from underneath, and then hopefully these will just attach in. That's better. We're going to bring this video to an end, guys, because I had all of the best intentions of fitting the throttle and the mixture lever here, but in transport I've just realised that the throttle is missing, and it's supposed to be on the shelves behind me here, but it's just not. That's a good opportunity anyway for the next video to build the throttle and the mixture lever, and it's got two modes of operation. You can screw it in and it's got a micro adjustment all the way, or you can push the silver button at the end and then just freely move it backwards and forwards. Wherever you release it, then you can just screw it for micro adjustment as well. It's not a complicated mechanism, but there is a ball bearing and it runs on a ramp backwards and forwards, and there's a couple of springs in there. So the next video hopefully will be how that's created along with the throttle, because I need to create that next. I also definitely haven't created the static air pull-on button. In fact, there's one more thing I want to do, and that's to fit the laser panel. As I've made it, it'd be silly not to fit it. So let's get that in and we can see how it looks. And that now should slide in as a direct replacement. That's the lower panel fitted. And then I just remembered, while I was creating that, in true Blue Peter style, here's another one I created earlier. And again, this is a laser panel. If I put this next to the side here and bring the camera in, we've got the 3D printed one here, which actually I'm really pleased with. And then we've got the laser etch one here. Let's swap them over so we also get that finished look. So hopefully this panel now is just going to slide in as another direct replacement. It should do in theory. Now this is completely backlightable, which is the main reason why I'm changing it, as well as the fuse panel. This avionic panel has a 3D printed back case You can see that it's got the LED strips inside there. They light up the back panel from behind and stop any stray light from the external sources lighting up the panel from the rear. Not going to fit that right now. Got a few more developments to do on it. Let me show you some other ideas that I've got. Right, GMA 1347 Garmin audio panel. Hopefully that's focusing. Is it focusing? There we go. This one is laser etched. It's fully backlightable from the rear. So these buttons fit in really well. Move my finger out of the way and they push in really well. You can read the text hopefully really well on there as well. And big encoder that goes at the bottom. That's going to go in the center there. Oh, it's going to look fantastic. The next mod. Now, this is the G1000 version 2. It's almost complete. All I've got to do is add the structure on the back to house the PCBs that come with it. That's the display driver board, the power board and the menu board. They'll be mounted on the rails and of course the Arduino again in the same place. This is a slightly different size. Oh, it's about 10 millimeters bigger, wider. It's a little bit thicker to house a bit more content. It's got the new LCD display in there, the high contrast one. And that is going to fit in there. So here we've got the 3D printed G1000. We've got the laser etched GMA 1347 and then we've got the other G1000 again. It's 3D printed but it's got laser etched panels. So it makes the quality look so much better. Fully backlightable, and once I get around to it, these laser etched panels will be available on the website for purchase. But it's got a little while to go before they're out. And I guess the very last thing to show you, there's a lot to do still, is the instruments. Now, these two are not designed. That's the VSI, I believe. No, vertical speed. Yeah, vertical speed indicator and the altimeter. The ASI is designed. Got this lovely coloured decal. It's laser etched on 3 different colours. And when that's backlit, it really makes a difference. That's going to sit in there like that. In fact, this is going to be mounted from the rear. It's a bit of a tight fit, but it's going. There we go. And that will go in there with all the rest of the gubbins. Now, I actually did have a prototype made, and I had one specifically made for this cockpit, but once again, I cannot find it. It's probably still in the boxes that I've not unpacked for the sim yet, because there are a lot of boxes back there. That's it for now, guys. Until later, sim out.